In this video, we'll extend what we know about subtracting a positive from integers to move to subtracting positive rational numbers, so decimals and fractions, whether we're starting with a positive or a negative. As a recap, looking at specifically integers, the first case we considered is if you're starting with a positive number, so something like 12 minus 7, or maybe something like 12 minus 37. The sign of your final answer depends on where you're starting and how much you're dropping by. So if we start with this first example of 12 minus 7, I'm starting in the positives at 12, and I'm taking away less than what I started with. So I would expect to still end up in the positives. Whereas if I'm starting here at 12, but taking away 37, I'm taking more than what I had. So that would force us into those negatives. So you can see it really depends, the sign of your final answer, on how much you're starting with and how much you're taking off of that. By comparison, if we're starting already in the negatives, that sign will stay negative because we're dropping more, or I like to think it's getting more negative. And it doesn't matter how small those numbers are or how much you're taking away. So if I'm already at a -2 and only dropping 7 from that, it's forcing me further into those negatives. Whereas even with larger numbers, the same result would happen. Starting at -12, dropping 27 more from that, it's just going to force us farther and farther into those negatives. So as far as determining the sign of your answer, again, you really want to focus on where are you starting and how much are you dropping from that. So 18 minus 30, I'm starting in the positives but taking more than what I had away, so that would force us to a negative answer. For number 2 and number 3, we're already starting in the negatives and dropping further, so that's getting more negative on both of those. But in number 5, I'm starting at positive 16, subtracting 5. I have more to start with here, so that would keep us in the positives. As far as actually getting that answer, you can think of every subtraction problem as its equivalent addition problem. And we talked in class about imagining a little plus sign in between those two. So -5 minus 11 is the same as -5 plus -11. And let's talk about what subtracting means. Subtracting a positive is like taking away a positive. So if you take away positives, that's going to get more negative. So getting more negative would be that adding a negative. So these things would have the same result. So here, this helps me see that they are the same signs. So I would really add those base numbers together. 5 plus 11 get me to 16. And since they're both negative, my answer would stay negative. For me, I'm a very visual person, so when I see problems like this, I kind of visualize that number line. So I'm starting at -5 and dropping further from there. So that helps me see that I would end up with a more negative answer, and -16 makes sense. We can use the same strategy if we're starting with positives. So here I have a positive 35 that I'm subtracting 57 from. That would be the same as 35 plus a -57. Again, subtracting a positive is mathematically the same as adding a negative. So that helps me see that these are different signs, and I would really subtract those numbers. So for me, I would set it up as 57 minus 35 to help me get that number. And I see that I have more negatives. So my final answer here would be a -22. If the visuals help you, we're starting here at 35 and dropping 57 from that. So I see I'm taking away more than what I started with, which is why that final answer would be a negative. So just like positive and negative rationals follow the same addition rules, they also follow the same subtraction rules. So we can keep using the same strategies that we have been using for integers on those messier numbers like decimals and fractions. So we'll do 2 examples of each. It might help you, since it might be harder to visualize that answer right away, to really think of these problems as addition. So -0.04 minus 0.58, or 4/100 and 58/100 would be the same, again, as if I added a little addition sign here and kept that second number as a negative. And then I can see that these are the same signs, so I would set it up as adding together those base numbers and then keeping my final answer as that negative. Or again, conceptually thinking, I'm already in the negatives and dropping even further. So that answer is getting more negative. For this next example, again, it may help you to think of it as 4/100 plus a -1 and 89/100. I can see that these are different signs. So instead of setting it up as addition, I'm actually going to think of it as subtracting those base numbers. And then I can see I have more negatives, or I'm taking away more than what I started with. So you can hopefully see it's the same process as if there were integers, just a couple extra things to do, like making sure I'm lining up my decimals, and I might need this step a little more than I would to just jump to the answer like you might be able to do with integers. Now fractions take a little longer because remember there's that step of getting common denominators. I recommend you do that first before you even try to rewrite it as addition if that's a strategy that helps you. So for 9 and 6, the smallest common denominator I could use would be 18. So I can multiply the 1/9 by 2, so changing that to 2/18. And then the 5, 6 I can multiply by 3 to help me get there. So 1/9 minus 5, 6 is the same as 2/18 minus 15/18. Or again, I could change that to addition if that helps you. So I could think of it in this way. Remember, once you get common denominators, you're really able to focus just on the numerators. So 2 plus -15, I have more negatives and they're different signs, so I would technically subtract those. So I would get a -13, and I just keep that same common denominator. So in a way, I think these are easier than decimals because I can jump to this answer faster than I'm able to with decimals, but that might just be me. If we look at this next one, same thing, just starting with a negative fraction instead of a positive like we did that last time. So start with common denominators, 5 and 4, a good one to be 20 as a common denominator. So 4/5 would change to 16/20, 1/4 would be the same as 5/20, and then not forgetting my signs. Now, for me personally, I like to write my negative symbols for fractions up in the numerator, so I might actually move that to kind of attach to that 16. So you may be able to get to the answer just from here, thinking of -16 minus 5, so dropping further into the negatives. If you need to, you can rewrite that as addition, so -16/20 plus a -5/20. And then maybe that step would help you get to that final answer. So these are the same signs, or again getting more negatives, so I would add those together to get me to a -21/20. I'm fine with improper fractions. If you wanted to change that to a mixed number, remember the process is the same as if it was a positive, but that negative goes out in front.